Hi there. So I will be talking to you today about how to integrate React with D3. My name is Fitzsimons, and I've been doing this for several years now. And I think I've tried many different approaches, and I think I've found the best way. And I'd like to share that with you today. And hopefully it will help you. um, so a bit about myself. I have a project called Number Picture, which has the aim of discovering and ranking all the possible charts that you can get. Currently, we've got more than 450 types of charts, uh, and this is up to 3 visual variables per chart. So there are many more, but those are the constraints we set on ourselves. And what I wanted to do was I wanted to be able to make the charts more accessible by enabling people to use them. By writing code, they could visualize their data and use these charts. So I started out considering how I would go about creating 450 chart templates for people to use. And this is quite a challenge, obviously, because it could take years to do. But in order to do it, I needed to think about I couldn't use an existing charting library because no charting library in existence has 450 charts. So I needed to think about it in a different way. And this is a quote that comes from Mike Bostock, the guy who made D3. He used this quote that elegant design requires us to think about a theory of graphics, not of charts. And this is what informs his approach to D3 and the way it is designed. So this is very similar to it's exactly what I needed for to make my charts for Number Picture. So I looked around to see what existing libraries there were available at the time, and the vast majority were charting libraries. But obviously, I didn't need a charting library. I needed something more low level. And when I talk about graphics, I'm talking about graphics in terms of shapes and symbols and what they mean, not about computer graphics. I'm talking about the graphic design more and how it can be applied to data visualization. So the only graphics libraries I found were D3, which has an imperative API, so it's going to take me years to write 450 charts, and also it can tend to be a bit messy. Not messy, but you can very easily run into a situation where you have lots of spaghetti code and that sort of thing. So I knew from the beginning that D3 wasn't going to be good for what I was doing. And while I was while I was on the journey to finding the solution, a library called VX appeared, and it was very close to what I needed, but the only problem was that it wasn't animated. So basically, I set out to make my own library, and I'm going to take you through the approach that I found to be the best way after several iterations. So let's firstly look at what D3 and React actually are and what they're good at. I mean, D3 is multiple things, but in my opinion, where D3 really shines is when taking abstract data and mapping it to the visual realm. If you let D3 interact with the DOM, then you're in a situation where you're limited to only visualizing data in the browser. You can't do server-side rendering. You can't use it in React Native, for example, or in a native environment, mobile environment, and you also but it is very good at doing high performance animations in the DOM. And React, on the other hand, is a library that is not coupled with the DOM necessarily, but it is very and it is very good at declaratively controlling the DOM or the other environments that you use it in, like React Native, or and it also has many positive design attributes. So you're able to build highly modularized applications. You have abstraction, decoupling, etc. Lots of good things which I'm sure you guys are already aware of. So I won't go into too much detail. So the criteria I set out with when I started to make my library was that firstly, it should be animated. It should have high performance. It should be, the code inside the library should be elegant and not feel like a hack. And before I get to the fourth criteria, I want to take a quick criterion, and talk to you about how I believe the optimal way is to break charts up into their components or their elements. And I mean, obviously the data is separate by nature, but I think the actual chart, it's a logical way to separate it into a layout and into nodes. So the layout performs calculations in order to lay out the shapes on the page and position them and tell you their attributes, like where their size, their angle, etc. But it actually doesn't do any rendering itself. And then the layout maps the data to nodes which are in charge of rendering the actual shapes on the page. And I think this is a clever approach to take, because each part of the visualization can be interchanged with other parts. So, for example, you can use different data sets with the same layout and node. You can also use the same data set and the same nodes, but switch the layouts. And then you can also have the same data layout, but switch the nodes shapes. So, for example, you have a stack with bars or a stack with areas. And so this brings me to my fourth criterion that I think is important, and that is decoupling the elements of the chart. So, as I said, I went through many iterations and different approaches, and everything I found online, someone was saying this is the best way and the only way that you can integrate React with D3. But they never showed you alternatives, so I had to manually go and attempt each one. And in the end, the one that I found to be the best in terms of all these criteria was the following. So, so on the left you can see we have the layout component, and at the bottom we have the node component. And what happens in the layout is that it receives, well, on the right you can see how you use it. So it receives data as a prop, and then on the left in the render method it will take that data and it will enrich the data using a D3 layout, for example, like a pack or a stack or a tree map, etc. All the layouts that you get in D3 can be applied here. So it will enrich the data and add extra properties to each datum. Like if it's a pie layout, it will add start and end angles to each datum. And then what it does is it passes that enriched data to the children. The children, which is a function, so it uses a render prop pattern and passes each tick of the animation. It passes the enriched interpolated styles to the children render prop. And then the nodes at the bottom, and sorry, I forgot to mention that we're using React motion, transition motion. So, and then the nodes, what happens at the bottom is the nodes are just stateless components that take some inputs and render something to the screen. So you can see on the right, you have the layout, you just pass the data gets enriched and passed to the render prop, which happens to be the children prop, and then that gets mapped to a bunch of nodes on the screen. And then, okay, so let me tell you why I think this is the best approach. So firstly, the nodes are stateless components. Secondly, the layout is only recalculated once each time the dataset changes, each time it receives new data. And the React Motion or React Transition Group version 2, it tweens this, well, it interpolates this new data in a very simple way. So it's just interpolating raw values. It's not like doing any transformations each tick. And each tick, it passes the intermediate interpolated data to the render prop, and the stateless children, they each render efficiently each time. So it meets all the criteria. It's animated, performant, elegant, and decoupled. So here it is. Here's a diagram of what happens. So you have your data. The data comes in. You don't change the data. You don't interpolate the data at all. You just literally pass it to your layout. The layout recalculates once only, and then after the layout has calculated, you perform a simple interpolation just from one set of numbers to another, one array of numbers to another. So you're not doing any transformations in the middle, each tick, and then the interpolated data gets passed to the stateless nodes, which are rendered to the screen. So in this way, we have the lowest time complexity, and it means it's the best way to separate and construct a chart. So using this approach, I built a library which is called NumberPicture.js, and what it is it's a whole lot of low-level building blocks for constructing animated visualizations. And on the left, you can see these are the shapes and shapes and elements that I've implemented so far. You have simple shapes like circles, rectangles, lines, and text, and then you also have generated shapes that generally use D3 generators like arcs, areas, symbols, and ribbons, and radial areas, etc. And then on the right we have the layouts. So these are all declarative. Well, these are all components that are that use D3 layouts to, if that makes sense. So basically, the way I showed you previously, you have your. Let me show you. So on the left, in the layout you use the D3 layout function. So that that is here. Sorry. So the layouts each use a different layout function from D3, and they map that enriched data to the render prop and the children that you pass it. So let me show you an example. Here we have a pie chart, and what you do is you import the components from number picture, SVG, pie, and arc. The SVG literally just renders a SVG element, and then the pie layout takes some data, and the value and ID props, you see those are the accessor methods that the D3 layout uses to calculate the layout. And then you just have an animate prop, or flag, which tells it to be animated or not. And then in the children prop is a function that receives an array of nodes and then maps them to an array of React elements that get rendered on the page. So here we're mapping them to arc elements. Arc. We're using the arc component, and the API is designed to be as close to the API as D3 and native SVG as possible, and you just pass the props that you want. So here we're passing start angle and end angle, and the rest are hard-coded static props. And you see on the right what you've got is a pie chart, and it's animated, so each time the data changes, it will tween to a new state. And out of the box, this even works on React Native because we're not interacting directly with the DOM, and we're using a component injection. So what this means is, you see here on line 4 and further down in 3 places where in the comments it says here, we're injecting the component that needs to get rendered to the screen. So the SVG component uses the React Native SVG component to render. The pie layout uses the React Native SVG group component, and the arc uses the path component. So almost out of the box it works with React Native, which is pretty cool. And the roadmap for where I see this going is that firstly I want to improve the React Native support, because there are some things that are not totally compliant with native SVG, and there are some workarounds that need to be made in the library. Secondly, I want to add extras like legends, tooltips, axes, patterns, gradients, and lastly to add canvas support for performance reasons, and also for whoever wants to use it on canvas. I mean, it's good to have the possibility. And yeah, any help, if anyone is interested in helping with this, getting to these goals, it would be very welcome. And that's it from me. If you like to try Number Picture out, you can install it using the next tag from npm. And here are several links to everything that I mentioned in this talk. And that's from me. Thank you very much. Yeah.